This is the second part of the chapter on periodic table. I have drawn the modern periodic table in the shorter version of the modern periodic table, which you have to know. Okay. You don't have to know about all the 118 elements. Okay. You have to know till 20. Okay. These numbers which are there, which are written with each element, is the atomic number. Okay. So, as I told you before, Moseley arranged it according to atomic number. So, you will see that 1 is here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and that's 20. So, you have to know till atomic number 20. Okay. Now, about the arrangement. As I told you, this way are called periods. So there are 7 periods, 1, 2, 3, 4, 5, 6 and 7 periods are there, and this arrangement, okay, that is vertically, are called groups. Okay. So that's group 1, group 2, I have left out 3, 4, 5 and so on. So next is group 13, 14, 15, 16, 17 and 18. I told you there are 7 periods and there are 18 groups. Okay. But everything you are not going to learn now, so that's why this, I said, is the shortened version of the modern periodic table. Okay. So, groups are these are the groups, these are the periods. Okay. So, you have period 1, 2, 3, 4, 5, 6 and 7, and you have group 1, which is also called 1A, group 2 is 2A, group 13 is 3A, group 14 is 4A, group 15 5A, group 16 otherwise called 6A, group 17 is 7A, and group 18 is 0 group. Okay. Now, in period 1, there are only 2 elements. Okay. That's hydrogen with atomic number 1. You will see hydrogen here as well as here. Why? Is hydrogen has the property of a metal as well as a non-metal. When it can have a property of a metal or a non-metal. So that is why it's placed under metals here. It is also placed under non-metals here. Usually you will find metals on this side, non-metals on the other side. Okay. So hydrogen has both properties. That is why hydrogen is placed here and also here. So it's placed under group 1, it's also group under group 17. It's the same thing. Okay. So I said period 1 has 2 elements. One is hydrogen, is the same, and the other one is helium, having atomic number 2. Okay. Period 2 has 8 elements here. 1, 2, 3, 4, 5, 6, 7 and 8. Okay. There is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, I'll repeat. Period 1 has hydrogen and helium. Period 2 has Li is lithium, Be is beryllium, B is boron, C is carbon, N is nitrogen, O is oxygen, F is fluorine and Ne is neon. Period 3 has again 8 elements. The 8 elements are Na is sodium, Mg is magnesium, Al is aluminium, Si is silicon, P is phosphorus, S is sulfur, Cl is chlorine and Ar is argon. And period 4 has many elements, but you will learn only the first 2. Okay. That is, this is Ka, which is potassium, and Ca is calcium. Okay. So these elements you have to know. Okay. The 20 elements in the correct order, and each one belongs to which group and which period. These things you will have to know. So practice this table. Okay. Now, they are arranged this way, and if you notice, periods, if I take a period, let's take period 2. These are the elements in period 2. These are their atomic numbers. If these are the atomic numbers, these are the number of electrons. So this has 3 electrons, 4, 5 electrons, 6, 7, 8, 9 electrons and 10 electrons. Now if you have to write their electronic configuration, first orbit has 2, a second orbit has 1. 2, 1 is the electronic configuration. This one is 2, 2. This one is 2, 3, 2, 4, 2, 5, 2, 6, 2, 7 and 2, 8. You will see all of them have 2, 2 orbits. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Means one orbit having 2 electrons and the second orbit having different number of electrons. So there are 2 orbits or 2 shells. Okay. Because they have 2 orbits or 2 shells, that is why they are in period 2. Look at this one. Number of electrons are 1. If you arrange this, the electronic configuration is 1. If you arrange for this, it is just 2, which means it has only 1 orbit. That's why it is in period 1. 1 orbit it has. This one has 2 orbits. These ones have 3 orbits. You can check. 11 means 2, 8, 1, 2, 8, 2, 2, 8, 3, 2, 8, 4, 2, 8, 5, 2, 8, 6, 2, 8, 7, 2, 8, 8. All having 3 orbits, therefore they are in period 3. These have 4 orbits, that's why they are in period 4. So periods are actually the number of orbits they have or number of shells they have. Okay. So that's how they are arranged. But if we consider group, let's take group 1. All of them under group 1. Electronic configuration for this is 1, which means in the outermost orbit it has 1 electron. Electronic configuration of this 3 means 2, 1, which means the outermost orbit has 1 electron. For this electronic configuration is 2, 8, 1. The last orbit has 1 electron. For this 2, 8, 8, 1. The last orbit has 1 electron. If you see all of them, their last orbit has 1 electron. That's why they are under group 1. All these will have 2 electrons in their outermost orbit. That's why they are under group 2. And so on. Okay. Now, those under group 1, these elements, except hydrogen, these elements, okay, they are called alkali metals. They are called alkali metals because these ones react with water readily to give you an alkali or a base. Okay. That's why they are called alkali metals. These ones are called alkali metals. So that's why I put under group 1, they are called alkali metals. These ones are called alkaline earth metals. Now why they are called alkaline earth metals is they are also basic alkaline, okay, and they are found on the earth's crust. That's why earth metals. Okay. So these are called alkaline earth metals. Those under group 7A, fluorine, chlorine, okay, iodine, all these ones are called halogens. These elements, fluorine, chlorine, iodine, etc., are called halogens. Okay. And the ones in the last group, that's group 18 or group 0, okay, helium, neon, argon, krypton, xenon, all these, okay, are called noble gases because they are completely filled. They are completely filled, that's why they belong to group 0. Okay. Now, some of these I have shaded. I have shaded these two with red. Okay. That's boron and silicon. These have the properties of metals as well as non-metals. Metals usually are on this side of this line. Okay. All these are metals, and the other side of this red portion are non-metals. And these ones have both the properties. That is, they behave like a metal as well as a non-metal. Okay. So these are called metalloids, the red ones, okay, which are here shaded like this are called metalloids. And I have also shaded few of them blue, these. Okay. These ones lie on the other side of metalloids, therefore they are non-metals. Anything on this side of the metalloids are metals. These are all metals, okay, and these are all non-metals. So the ones which are shaded blue are non-metals. Okay. So these are few things that you have to know about modern periodic table. Okay. And as I told you, how they are arranged. Periodic table is arranged according to periods and groups. Okay. So as I told you, period is actually arranged according to the number of shells. They have the same number of shells. If they belong to period 1, which means they have one shell. All of them have one shell. If they belong to period 2, which means they have 2 shells. If they belong to period 3, which means they have 3 shells. If they belong to period 4, they have 4 shells, and so on. Okay. Period 1 is the shortest period. Okay. It is the shortest period. You can see the previous one. Period 1. This is the shortest period. Why shortest period is it has less number of elements. There are only 1 and 2 elements. Okay. So period 1 is the shortest period consisting of 2 elements. The 2 elements are hydrogen and helium. That's why it's called the shortest period. Period 2 is a short period with 8 elements. Period 3 is also a short period with 8 elements, whereas period 4 and 5 contain 18 elements in each of them. 4 has 18 elements, 5 also has 18 elements. Period 6 has 32 elements in them, and period 7 has 26 elements. Okay. So this is the arrangement according to periods. If you go to groups, that is arrangement vertically. Now how they are arranged in groups is depending on the number of electrons in the outermost orbit. How many electrons are there in the outermost orbit? Okay. So that is same valence electrons, means number of electrons in the outermost orbit should be same. If they have 1 electron in the outermost orbit, it belongs to group 1. If they have 2 electrons in the outermost orbit, they belong to group 2, and so on. Okay. So group 1A, the first group 1A are called alkali metals, which I mentioned before. Group 7A were halogens, and group 18, the last one, are called noble gases. Okay. So that's about groups. So you know that these elements were arranged according to their periodic properties. I mentioned the periodic properties in the previous class. Okay. The first periodic property is called the atomic radius. The atomic radius, let's say if I draw an atom, that's the nucleus, that's the first orbit, and say the first orbit has 1 electron. Okay. The atomic radius is the distance between the center of the nucleus and the outermost shell. It is the distance between the center of the nucleus. This is the nucleus, the middle one is the nucleus. From the center of the nucleus, okay, from here, the distance between the center of the nucleus and the outermost shell. This becomes the outermost shell, so this distance is called the atomic radius. The distance from the center of the nucleus to the outermost shell. That is called the atomic radius. Okay. The second periodic property is called ionization potential. This is the amount of energy required to remove an electron from the outermost shell of an isolated atom. Imagine this is an isolated atom. It's separate. Okay. It's not combined with anything. It's separate. Okay. So this is an isolated atom. Ionization potential means the amount of energy required to remove an electron from the outermost shell. This is the outermost shell. Okay. This one is the outermost shell. And you can see there is an electron there. Now if you have to remove this electron, okay, that electron has to be removed. Now there is some energy that is required to remove this electron. Just like that you cannot remove. Okay, you require some energy to remove this electron. That amount of energy to remove that electron, okay, is called ionization potential. Okay. That's the second one. The third one is called electron affinity. Okay. Electron affinity means the amount of energy released when an atom in the gaseous state accepts an electron to form an anion. Okay. Like say an atom of sodium combines with an atom of chlorine. Okay. There is one electron in sodium and there are 7 electrons in the outermost orbit in chlorine. Okay. Now this electron is given there. So this is completely filled, this is also completely filled. Okay. Now it says electron affinity is the amount of energy released when an atom in the gaseous state accepts an electron to form an anion. What this one has done is this in the gaseous state. Okay. Now this accepts one electron. To accept one electron, there is some energy, amount of energy that is released. Okay. To remove an electron, the energy is required. To accept an electron, the energy is released. So the amount of energy released by accepting an electron to form an anion. Anion means negatively charged particle. Okay. Because it received one electron, electron is negatively charged. Because it received one electron, this becomes negatively charged, this becomes positively charged. This becomes an anion. Okay. So to form an anion, there is some amount of energy which is released to accept this electron. Okay. That amount of energy is called electron affinity. Okay. The fourth one is called electronegativity. The tendency of an atom to attract electrons towards itself when combined in a compound. I can show you the same thing. This one. Okay. Electronegativity means the tendency of an atom to attract electrons. This one attracts electrons. Okay. This one doesn't. Sodium doesn't. Sodium always wants to give. Chlorine wants the electrons. So it wants to attract this electron. So the tendency of an atom, for this atom I am talking about, the tendency of an atom to attract this electron, to pull this electron towards itself, attract an electron towards itself when combined in a compound. They are going to form a compound. The compound which is going to be formed is NaCl. Okay. So the tendency of this atom to attract the electron, such tendency is called electronegativity.